Hello everyone, let's continue here to finish the last couple of slides that we left for this chapter. So after you can define something is a binomial experiment, then let's look at some notations we have here. So probability of success. So let's just still use the same probability experiment. Toss a coin 3 times. So probability of success, and then we focus on head, right? So heads received, X, B, head received. So X is the random variable that describing head received after toss a coin 3 times. So probability of success, in this case, is just probability of landing head. That's just 0.5 in this case. Not all the time, right? Other case, if it's not a fair coin, then this might change, or it might represent other things for that specific binomial experiment. But for this one, probability of success is the same as probability of head, and probability of failure is just 1 minus probability of success. The other side, right? Or it's just probability of tail in this case. And then we use little p to represent what we have here. So little p is just that number 0.5. And little q is just 1 minus p, because it's just the probability of failure, right? So 1 minus p. In this case, it's just 0.5. And then n is the number, the fixed number of trials. And then x be the number of success in n trials. Number of success in n trials. So number of heads in 3 tosses is the same as number of successes in n trials. And then x gonna take value from 0 to n, right? So for this one, x I take what? 0, 1, 2, 3. So that's just the notation. And knowing the notation, then we can again look at our table, right? X can take value from 0, 1, 2, up to n, right? So n is 3 for this case. And then probability of x, take the corresponding value. Then we can find all the probabilities, right? We know what it is. But being a binomial experiment, this is a binomial experiment, right? The probability, we don't have to use a tree diagram. We have a formula for that probability. So the probability of x equals x can be, so those numbers can be calculated. Can be calculated. So that is calculated by what? So n choose r, that's the combination we learned from previous chapter. So n choose r times the little p to the power of x. 1 times 1 minus p to the power of n minus x. So that's how we calculate it. So let's see. So we know this is 1 over 8. It's 3 over 8. 3 over 8 and 1 over 8. Let's see this value. Probability of x equals 2. So can we get 3 over 8 using the formula? Let's try it, right? So that tells us what? N choose r. N choose, not r, I'm sorry. N choose x. N choose x. So that is what? 3 choose 2 times the little probability, p, little p is 0.5, right? To the power of 2 times 1 minus 0.5 to the power of 3 minus 2. That is 3 choose 1, right? 3 choose 2 is same as 3 choose 1 times 0.5 to the power of 2 times 0.5 to the power of 1. So that's basically 3 choose 1, we got a 3, right? Times 0.5 to the third power. So that's 3 times 0.125. That is 0.375. 0.375. And then it is same as what? 3 over 8. So not only for this 2, you can calculate the rest always using the formula. So it just makes the process a little easier. Then let's look at this example. A coin is tossed 3 times. Find the probability of getting exactly 2 hats. So that is done. And then a coin is tossed 3. Find the distribution of getting hat. So again, x is the random variable. So and then we just want to finish this table. 0, 1, 2, 3. So probability of x equals x. So we got 0.375 here. And then let's just calculate the rest using the table, right? Using the formula. Equals 0. That is going to be, so the formula is what? N choose x, p to the power of x, q to the power of n minus x. So that's what? 3 choose 0 times 0.5 to the power of x 0 times 1 minus 0.5, right? That's 0.5 to the power of 3 minus 0. So 3 choose 0, that's just from a bowl of three balls, and then you want to choose nothing. So one way to choose nothing, right? So that's 1 times 0.5 to the power of 0, that's 1. 0.5 to the power of 3, that's 0.125. So we fill that in. Probability of x equals 1. That is 3 choose 1 times 0.5 to the power of 1. 1 minus 0.5. That's 0.5 to the power of 3 minus 1. So that is 3 times 0.5 to the power of 1. That's 0.5 times 0.5 to the power of 2. That's 0.375. So put it here. And then probability of x equals 3. That's 3 choose 3 times 0.5 to the power of x. 0.5 to the power of 3 minus 3. So that is 1 times 0.5 to the third power times 1. Because 0.5 to the power of 0, that's 1. 0.125. So we complete this distribution table by using the formula of the probabilities. Since it's binomial, so we have this easy way to calculate it. So then we have something called binomial table. So binomial table is just a list of all the calculated probabilities. So for this one we know what? N equals 3. The little probability of success, little p equals 0.5. That's the probability of success, or probability of hat, right? N equals 3, p equals 0.5. Then x can take what and the corresponding probabilities. We can use a computer to calculate all kinds of combinations between n and a little p, right? And store in a table that is called the binomial table. So for the previous one, we have n equals 3. So n equals 3. We circle that here. And then probability equals 0.5. So this is what? The probability distribution, right? So x can take 0, 1, 2, 3. So when n equals 3, x can take what? 0, 1, 2, 3. And with the corresponding probabilities, that is 0.125, 0.375, 0.375, and 0.125. And that is the binomial table. And if you want to read when x equals 2, because for the example that a coin is tossed 3 times, find the probability of getting exactly 2 heads. So that is probability of x equals 2. Then those are the facts you're going to look at. 3.5, locate the table, and then circle 2, 0.375. You got that number from the table. That's how we use this binomial table. Okay, so let's say example. Toss a coin 6 times. Let x be heads. Count heads observed. And we want to find the binomial table, right? Find the distribution. Using the table. Then how can we find it? So we just circle n equals 6 now, right? So we circle that 6. The possible values are right behind, right after the 6. You have all the possible values of x. X can take 0, 1, 2, 3, 4, 5, 6. And then again, probability is 0.5 because it's toss a coin, right? So this is the corresponding probabilities. And if we want to see exactly 4 heads, so probability of x equals 4. That is the number 0.234. That's how we use this binomial probability table. And everybody knows that, right? We have a separate video talking about how to read the table. So you can watch that video as well. And we also have a table called cumulative table. The only difference is cumulative table stores the cumulative probabilities. So what is cumulative? Up to that number, right? So up to 0, we have 0.125. Up to 1, we have those two all together, right? The cumulative means up to that number. So we have 0.5. Up to this number, up to 2, we have 0.875. Up to 3, we have 1. So this is called the cumulative one. Reading the binomial probability table is required. Reading the cumulative table is optional. It's optional. So if you're interested in using that kind of table as well, then you can also watch the video that we post on Blackboard and to see how we use that kind of video. Reading the binomial probability table give you all the probabilities, and then you can solve all the questions already using only this table. But sometimes using the cumulative table might be faster or easier to read. It just depends. We will not introduce more about it here. If you want to know more, then watch that video on Blackboard. Okay, and then the mean and variance standard deviation for a binomial distribution. Then we have, of course, the easier way to do it. The mean, or the expected value, is just n times p. And the variance is n times p times q, which is 1 minus p, right? And standard deviation of x, which is square root of n p q, or square root of n times p times 1 minus p. Square root of variance. As long as you get the variance, you got it. So then we want to calculate the mean, the variance for for toss a coin 3 times, right? This is the probability distribution for toss a coin 3 times. So we know mean of x equals 1.5, and variance of x equals 0.75, right? And let's verify that using the formula we learned. So mean of x equals expected value of x equals n times p. That is 3 times 0.5, 1.5. So verified. And variance of x equals n times p times 1 minus p. So 3 times 0.5 times 1 minus 0.5. So that's 1.5 times 0.5. 0.75. Verified. And standard deviation of x is just square root of that 0.75. And of course that will still be the same. So using the specific binomial distribution formula going to make the calculation way easier. But again, you have to make sure the probability experiment is a binomial. Then we can look at this practice problem. A student takes a multiple choice exam with 10 questions, each with 4 possible selections for the answer. A passing grade is 60% or better, and suppose that the student was unable to find time to study for the exam and just guess each question. We want to find the probability that the student A gets at least 1 question correct, B, C, and D, answer all those questions. Then we just learned binomial. So let's see whether this is a binomial experiment. So number 1, fixed number of trials. Do we have a fixed n? Yes, right, 10 questions. So n equals 10. And then 2, so 2 outcomes. So answer a question, correct or not, right? So 2 outcomes. Fixed number of n, 2 outcomes, and independent. Yes, right. For any question, if just a pure guess process, then no influence, right? Whether correct on number 1 doesn't affect whether correct on number 2. So definitely independent. And then 4, the last one, probability of success is probability of correctly, right? Correct. So that is what? 1/4, right? You have 4 choices, and then you have to select 1. That is 0.25. And 4 conditions for a binomial experiment all verified. So this is a binomial distribution. So x represent the number of questions that a student can get correctly. So let x be the number of questions the student can answer correctly. Then we say what? X follows a binomial distribution with, we have to define n and p for a binomial distribution. So n is 10, p is 0.25. So binomial 10, 0.25. N and p. Okay, so that fixed the binomial distribution. Recall the table, right? If you have n and p, then you know all the informations, values I can take, and the corresponding probabilities. Okay, so got at least 1 question correct. So in a stat notation, that is probability of x more than or equals 1, right? So because x can take 0, 1, to 10, right? So 2, 3, 4, 5, 6, 7, 8, 9, 10. And the probability of x. So at least 1 question correct. So that's from here, right? To here. 1, probability of x equals 1. Plus probability of x equals 2. X equals 10. So you have 10 terms to add up together. That's hard to calculate. We also know the sum is 1, right? So if we want to know the sum of all those values, we just need to use 1 minus this one. Take this one out, and then that's the sum of the rest. So that's actually 1 minus probability of x equals 0. So 1 minus what? Let's check the table. So n equals 10, right? N equals 10, and probability equals 0.25. So right here. So these are the probabilities. Probability of x take 0, so that's 0.056. So that's just 1 minus 0.056. That is 0.944. So the student got 94.4% chance to get at least one question correct. So which is very high. And receive an A. Let's see whether still the student got a high chance to receive an A just by pure guess the answers. So that is probability of x more than or equals 9, right? So answer 9 question 90% or better. So that is probability of x equals 9 plus probability of x equals 10, right? Only that two options. So let's go back to that table. For 9 and 10, those are all empty, represent a value of 0. Then that's what? 0 plus 0. That is 0. So no chance the student can receive an A on the test. And then how many questions would you expect the student to get correct? That's just the expected value, right? Expected value, or we call it the mean of x, that is n times p. So 10 times 0.25, that is 2.5. So we should expect the student got about 2.5 questions correctly. And then D, obtain the standard deviation. So standard deviation of a binomial case, standard deviation of x, that is square root of n times p times q, right? Q is 1 minus p, so we can just write 1 minus p directly. That is square root of 10 times 0.25 times 0.75. 1 minus 0.25, that's 0.75. So let's calculate it. Square root of what? 10 times 0.25 times 0.75. Okay, 1.369. That is the standard deviation. Okay, that's all for this chapter. And don't forget, we have worksheet 5 and homework 5 due the Tuesday after the spring break week. Okay, thanks for watching.